All right, so for 5-2, day 2, for piecewise defined functions, I want you to take a second and try out this first part. So we are going to do this, this part right here. So 1 and 2, and then you'll do A, B, C, and D as well. Okay, so go ahead and get that done, and then I'll start going over it. So if you looked at number 1, this was an absolute value graph. So you should have pulled out the vertex of -4, -8. Remember, opposite of the inside, same as the outside, right? That does make your axis of symmetry x equals -4. Remember, your domain is always going to be negative to positive infinity right now. And then our range, our lowest is -8, our highest is infinity. Now, increasing and decreasing I didn't write yet, and I want to just show this yet again. Some of you that had this in class have seen it this way, others have not. So I just want to recap this really quick. So you can put your boundaries, okay? You can put your options up there. All right, so I know that I'm going to write -infinity to -4. I just don't know whether that's increasing or decreasing. So basically what you're doing is -infinity to your axis of symmetry, and then that axis of symmetry to infinity. So then all you have to do is read it from left to right and figure out which one goes where. Well, if you focus on this first unit, that first part is decreasing if you look at it from left to right. So that means negative infinity to -4 is decreasing, and then -4 to infinity would then be increasing. On the second one, we have a graph here. So with our graph, we needed to put our boundaries. The boundaries are located in red, so that's at -4 and 1. Then I started with the blue line. So with the blue line, you either can start at -8 and work your way towards the line, or you can plug in -4. If you take -4 and plug it in, you get -1 times -4 minus 8, which means you would have 4 minus 8, which is -4. That means that we would start at -4, which we did, and then all we would have to do is move our slope. If you had a line that went this way, that just means that you just went in the opposite direction. Okay, this one's always the tricky one. Negative slope, you need to make sure you read it from left to right, and it is negative. The black line that I just drew would be a positive slope. So that one doesn't make sense. All right, and then the next one is the green one. I just graphed this like normal. So we would start at 7, move up 3/1, or down 3/1. Just be careful with the open and closed circles on those. And the last one in the pink was a solid straight line with an open circle because it's at -4. So then A, B, C can all be done based off of the graph. So you could have just looked at the graph, but I did show the equations as well that you should have used. You should have gotten -1, -4, 7, and -4. Now that last one is off the graph, but you know that it would be -4 just from the equation and the line that is given to you. So looking at today, first off, I don't know why it has this RST thing going on over here. This should just be the normal squiggle. So I think it says -x plus 12 and 1/2 x minus 2. Okay, so x is less than 8, x is greater than or equal to 8. Okay, so we'll use that. All right, so now if you're not given a graph, then you can't use the graph. And we've already done these before. All we have to do is determine which equation to use. Well, we're looking at 12. 12 is definitely greater than 8, so that means I'm going to use this bottom equation. So we would just plug in 12, 1/2 times 12 minus 2. That gives me 6 minus 2, which makes my final answer 4. On the next one, we have -8. So this is where you have to be careful. Make sure you pick the equation that is included with this value. So yet again, we would pick that bottom one because this is including 8 because it's equal to as well. So we plug in 8 and we get 4 minus 2, which is 2. In part C, we need to find 4. So again, we focus on our boundaries to figure out which equation to use. In this case, we would have to use the top equation because 4 falls in the category of less than 8. So we have negative 1 times 4 plus 12, or negative 4 plus 12, which is 8. And our last one is g of negative 3. So again, we need to figure out which equation to use. This one yet again falls into that top one because it is a value less than 8. So we would have negative 1 times negative 3 plus 12, which gives me 3 plus 12, which is 15. So hopefully that feels pretty familiar and simple to you because we did talk about that yesterday as well. I encourage you to pause the video and try these before I start going over them. All we're doing is exactly what we did in that last problem. So now we are going to plug in 8, and that's going to fall into the boundary of the last one because it is greater than 6. So that equation is just x, which means my answer would just be 8. If we're plugging in negative 6, that falls into the first category, so we need to plug it into this equation. So we have negative 3x plus 2 minus 8. So we have negative 3 times negative 6, because that's my new x value, plus 2 minus 8. And that makes it 18 plus 2 minus 8, which is 20 minus 8, which gives me 12. Our next one is 0. That would fall into that middle category, which is 2x minus 3. So for this one, you'd have 2 times 0 minus 3, which would give me negative 3. 6 is a tricky one. You need to make sure that you're picking the right equation when it is a boundary one. Because it's a boundary one, I need the one that says equal to, so that would be this bottom equation. So this would equal x, which means my answer would be 6. And then we have f of negative 3. This is also a boundary one, so I do need to make sure I plug that into the one that is equal to negative 3. So we have to plug it into the 2x minus 3. So 2 times negative 3 minus 3, which is negative 6 minus 3, which is negative 9. All right, so now we're going to focus on writing equations of piecewise functions. And these are things that I feel like you need to do a good job of piecing together. Haha, right? Piecewise, piecing together. So I'm going to show you how I approach it. Now you can go different ways, and that's totally fine. But my starting point is to just locate the boundaries. So the first one is going to be between these two x values, right? So I know it's going to say if x is between, right? Think about our betweenness, okay? Our lowest value, which is negative 4, and our highest value, which is 1. Which then means my next category also kind of just starts at 1, right? It's going to be 1 and then over. So that would be if x is greater than 1. Now, I always check to make sure that I put the right inequalities here. At this point, I realize that these two need a line underneath it because they are closed circles. Okay, from there, then just think about each equation on its own. Okay, if you need to, you can extend them so it makes more sense, but you don't have to. This first equation is just a line, right? So we start, we would move up 1. So that means my y-intercept is 1. And if you notice, your slope is also 1 because you're going up 1 over 1. So that equation is x plus 1. Then I'm going to look at my other equation. This one would be going in this direction, which means it's going through 0, 0. So it has no y-intercept. And my slope is negative 1, which would make it negative x. Now, you may not have to mark it up like I just did, and we'll look at that here in this next one. So again, we start with f of x and our squiggles, and then I'm going to put together our boundaries. So our boundaries are right here. at -2. So the first one is when x is less than or equal to -2. The next one is if x is in between -2 and our other boundary, which would be at 1. And then our last one is if x is greater than that 1. I do need a line underneath the one in the middle one. And now I just need to come up with the equations of each. So this first red one, right? This is a straight horizontal line, which just means it's just y equals a number. So that number looks like it's going to be about 1/2. The next one in green, it crosses over the x-axis at 0. And it looks like my slope, if I connect these two dots, would be up 1/2, so 1/2. So this one would be 1/2 x. And the last one's kind of tricky, right? It kind of looks like it would end up going through a not good point here. So I am going to have to come up with this equation a little different, right? I also have a bad starting point there. Okay, so what we're going to do is we're going to put together an equation through looking at solid points that we have. But now that I'm looking at it, there aren't really any. So, gosh, this one's tricky. I don't like this one. We're not going to give you ones that you can't really come up with the line that well with. So let's just generalize it, okay? So let's just say that this hits at 1/2. Okay, so it'd be plus 1/2. And it does look like it's going down 1/1 from there. The slope kind of looks like it's 1. Okay, so we'll keep it as just x. Again, these, I mean, there's no good point to really pick to scale it from, so we're just going to leave it like that. Okay, that will not be something that you will see on your homework or on your test. All right, so we have our last one here. Okay, so again, I encourage you to try this one on your own before you watch me do it. But again, we start with f of x equals, and then we have our squiggles. So the first one is if x is less than 1. The next one would be if x is between 1 and 4. And the last one is if x is greater than or equal to 4. Now this first line, hey, it goes through +4 as our y-intercept. And our slope, although it looks like it's going negative because we drew it to the left, it is a positive slope of 1. The next one is a constant, so that's straight across, which means it's just the number 2. And the last one, you can start using the slope of 1 that you see here, right, to try and figure out where you end up at, which would end up at -5. So we would have -5 with the slope of 1. Now you could always take 2 points or take a point and the slope. So we could use this point here of for -1 with the slope of 1 and put it into point slope form and then change it into y-intercept form. So then we would still end up with the same thing. Okay, so just keep that in mind. If you have to go that route, you totally can.